two answers. Millions of people have argued about this exact equation, and I mean genuinely argued. Comment sections, Reddit threads, people tagging their maths teachers. Before we go any further, pick one, commit to an answer. Here's what I want to tell you before we start. Everyone arguing in the comments is doing so in good faith. Both answers are defensible. The problem isn't the people, it's the expression. Here's the one thing both sides agree on. The bracket goes first. 1 plus 2 is 3. Nobody's fighting about that part. So now we've got 6 divided by 2, and then a 3 sitting right up against a bracket with no sign between them. And that little gap between the 2 and the 3 is where everything falls apart. The first camp reads left to right. Standard procedure, same priority. 6 divided by 2 gives 3. 3 times 3 gives 9. Clean, consistent, done. The second camp looks at that 2 sitting directly against the bracket and says, those two things are glued together. They're one compound term, so you divide 6 by the whole thing. 2 times 3, which is 6. 6 divided by 6 is 1. Two completely different operations, both sensible. Both following a rule. That's not a trick. That's what ambiguity looks like in practice. Right, so here's the claim I want to make, and I want you to hold it for a second before I prove it. This expression is grammatically ambiguous. Not wrong, not poorly taught. Ambiguous. Two people can read it correctly and get different answers, and neither of them is making a mistake. In any language, spoken or mathematical, the same string of symbols can have more than one valid structure. Linguists call this a parse tree, the branching diagram that shows how a sentence breaks into parts. Look at the left tree. Division and multiplication are treated as equals. Same priority, resolved left to right. 6 divided by 2 is 3. 3 times 3 is 9. That tree is internally consistent. Now look at the right tree. The moment a numeral is written directly against a bracket, no multiplication sign, just touching. Some conventions say that bond is tighter than explicit division. So 2 bracket 3 is 1 unit. 6 divided by that unit is 1, also internally consistent. 2 valid trees, 2 correct results, for 2 different expressions that happen to look identical on the page. Actually, before the fix, is this just one unlucky expression? Or is this a crack that runs through the whole notation system? Let me show you. 1 extra character, that's the fix. If the writer meant 9, they should have written it like this. Brackets around the first part. Open bracket, 6 divided by 2, close bracket, times open bracket, 1 plus 2, close bracket. No ambiguity. 9. If they meant 1, they should have written it like this. 6 divided by open bracket, 2 times open bracket, 1 plus 2, close bracket, close bracket. No ambiguity. 1. 2 extra characters, free of charge. The argument disappears. Every working mathematician, every scientific journal, every typesetting standard in the world makes this same point. If your expression can be read 2 ways, you've made an error. And the error is the missing parentheses, not the reader. Here's the thing, this isn't just a YouTube comment section problem. The American Mathematical Society, the main professional body for mathematicians in the US, officially recommends against using the obelus, the division symbol, in formal publication, not because it's wrong, because it's ambiguous. The fraction bar exists for a reason. Same goes for code. Type the identical characters into Python. You get 9. Type them into certain older basic interpreters. You get 1. Same keystrokes, different grammars. Neither language is buggy. They just made different choices about which rule to follow. And those choices were never stamped on the expression itself. And then there are the calculators, the detail that always surprises people in this argument. 2 physical calculators, same buttons pressed in the same order. One says 9. One says 1. Both are working perfectly. They're running different firmware with different precedence rules for implicit multiplication, and neither the box nor the keypad tells you which one you've got. The expression fails. The calculators don't. So let's say what this video has actually proved. The expression 6 divided by 2, bracket 1 plus 2 close bracket is underspecified. It has 2 valid parse structures. Each one resolves to a different number. Neither answer is wrong. They're answers to 2 different expressions that look identical. And the writer didn't tell us which one they meant. Here are both of these expressions, written clearly. One gives 9. One gives 1. Each is unambiguous. The original is not. There's a name for this in formal logic and computer science. An ambiguous grammar. A grammar is ambiguous when a single string of symbols has more than one valid parse tree. Mathematical notation is a grammar, and this expression is a sentence that grammar can't parse uniquely. The fix is always the same. Write it so it can only be read one way. Parentheses are free. There's no reason not to use them. And here's the thing that should end every one of these arguments online. When you see this format, a division sign, an implicit multiplication, no parentheses to separate them. What you're looking at is a malformed expression. The debate isn't about maths. It's about which grammar rule each person learned, applied faithfully to an expression that didn't earn the right to be ambiguous. Here's the question I want to leave you with. 8 divided by 2, open bracket, 2 plus 2, close bracket. Before you write your answer in the comments, write the version of the expression with parentheses that makes your reading unambiguous. Then tell me which one you think the original writer meant and why. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.